Hello, this is Mr. Bush here, and I'm going to go over how to do today's homework. On number 1 and 2, you just basically copy down the information. This is going to be really important for answering any of the other questions, so make sure you pay attention to what you write down. Let's go ahead and go down to some of our balanced and unbalanced forces. First thing for finding net force, you have to add and subtract the forces. If they're pushing or pulling against each other, you subtract, like in this picture here, and you add if they're basically pushing on the same sides. So, just to go back over it, if they're pushing against each other, as it shows right here, you would subtract. Basically, the 8 minus the 8 would equal a net force of 0. So, the forces would be balanced because they're equal and pushing in the opposite direction. Anytime you have a balanced force, the object's motion would not change, so you would go with it does not move. Let's go ahead and move over to our other one. If you look here, basically the forces over here on our right side, you would add them together, and because they're basically pushing together, so their total would be 20. Then you would subtract it from the forces pushing against it over here, and your total would come out to be 12 newtons pushing to the right. So that would be an unbalanced force because they're not equal, and the object would move to the right. Alright, let's go ahead and look at the one down at the bottom. Alright, if we look at, basically we have 4 different forces acting on it, 2 horizontal, 2 vertical. We're going to do the horizontal forces first. So, you have 8 newtons of force pushing here, and 8 newtons of force pushing here. They're pushing in opposite directions, so you would subtract, giving you a net force of 0 in the horizontal direction. Alright, so let's go ahead and look at our vertical forces real quick. You have 12 newtons pushing here, 7 pushing here. So you would also subtract. Now, you have 5 newtons left over pushing down. So the net force would be 5 newtons pushing down, and the object would move in the direction of the bigger force, which means it would move downwards. Let's go ahead and go over to the back. For problems 15 through 20, remember a balanced force will cause an object to remain at rest or continue at a constant speed. A good way to summarize that is the motion will not change. An unbalanced force will cause an object to speed up, slow down, or change direction. So we're going to look at a couple of these and then move on. On 15, it said the person was accelerating or speeding up, so that would basically be an unbalanced force causing him to fall down. On number 16, it says that he's driving at a constant speed of 60 meters per second. Therefore, that has to be a balanced force. On 17, he basically turns around. Basically, to turn, you have to change your direction. Therefore, it's an unbalanced force. Alright, let's go ahead and move down to the bottom ones. These are just like the ones you did on basically, I think, 4 through 14. You simply subtract if they're pushing or pulling against each other, and then you calculate whether it's balanced or unbalanced, and then determine which direction would move. It always moves in the direction of the greater force. So like on this example real quick, basically you have 10 newtons pushing in one direction, you have 60 in the other. So you would subtract, giving you 50 newtons. It's going to be an unbalanced force, and then this object is going to move in the direction of the greater force. Hopefully this is helpful, and you'll have a great day.